Okay, so yeah, hello everyone. Thanks DJ for the giving me another opportunity to speak here. So today's topic is much interesting now, like local and zoneless change detection. So everybody know, right? Change detection is one of the major aspect of Angular. Without knowing this, you may not be able to debug the application in case of you stuck at performance level optimization. So in today's topic, what we will do is we will go over the five different topics. So what is change detection and when it happens? That's a basic we will start with. Then we will see how to measure it. In order to check the performance, we should measure it somehow, right? The third one is what are the challenges that you may see with current change detection, and hence we have local change detection. And to extend that, we will see how the zoneless change detection can be applied. Okay. So yeah, a little bit about myself. I am Pankaj Parkar. I worked at Aeon, Angular JD, and also I was a Microsoft MVP. So moving ahead, we will start from basic. Okay. So a normal application architecture, what it has on front end. We have a state. Generally, people call it data model or state, right? We have a template to display things on the UI, and it appears on the DOM, right? Like first name Pankaj Parkar and age is also display. What are the framework's aim is? When the state change, magically we want to update it on DOM, right? And there are many frameworks that exist, and Angular also is one of it. And to do that mechanism, Angular use something called as change detection. Okay. So that's a basic. So what is change detection? So it's a synchronization process. Basically, it update model from your TS file to view. Okay, that's a change detection, simple thing, right? We take a very small example. We have an app component, variable, and also it has a template. It has a button, right? And on click of button, change title, we are updating title. So see what happens. As soon as we click on it, it gets changed. So you must be wondering how that is happening, right? So let's see how that happens. But before doing that, let's understand when the change detection triggered or happens from the Angular side. So there are only two things that you need to remember. One is browser handle event. Okay, what are they could be? Click, focus, resize, everything those are browser events. And the second one is asynchronous task. What can be asynchronous task? Network call, timer, or a promise driven task that can trigger a change detection. And this is like currently Angular don't know how to do it. So Angular use something called as Zone.js, which help to somehow get these things get to aware of these things, how it happens, and it lets Angular know, and Angular run the change detection. Okay. So when change detection is triggered, that was the thing, right? So there are two strategies basically to run the change detection. One is default, other one is on push. So we will look at a default strategy first. We have very simple example, and I'm going to ask a question. I know you are tired, but just try to give it an answer. Suppose we have a HTML like this. I just took component.ts class code. Line number 6 and line number 14, sorry. Wait a moment, yeah. Line number 6, line number 14, you see there is one network call, one task, and there is one start event function which triggers based on button click. Okay. So do you want to attempt how many change detection it will trigger as soon as I click on a button? 1, 2, 3, 4, 5. Just try to answer. So this is 3 API call. One is HTTP GET, the other one is set timeout. Yeah? 3, okay. Why? Correct. Very nice, good answer. Round of applause for this guy. Thank you so much. So yeah, basically it will trigger 3 API call. So one is the click event, which is browser handled event, right? The second one is, I told you, right, timer API. And the third one is HTTP GET, which is promise implementation, or maybe XML HTTP request API. Internally it may be using. So good. With default strategy, the way it works is, suppose this is your app. Inside app you have parent component and this has two child component and the other one has grandchild. What happens is, suppose, let's take an example of click event. A click event happens on child 1. What happens is, Zone.js get to know, oh, something happened, and it goes to the top of the hierarchy, root level, okay? And change detection always run from top to bottom in the tree form. So what happens is, it triggers the change detection at the top first, app level, then the child. Then it checks whether the left child exists. Yes, then it goes there. There is no more left child. Go to the next component and next component. This is default change detection strategy where everything, all components will be, since these all components are on change detection default strategy, they run the change detection, okay. So just before going to on push, I just want to make sure you understand what we're gonna do. So one question is how to measure change detection, right? In order to fix it or maybe improve it. So one of the major thing or very simple way to check change detection is Angular dev tools. I'm going to give a look at that, like how it looks like. The second one is a monkey patch application ref tick event, something like this. This can tell you whether it executed on the top level or not. It triggers on the root component or not. The third way is you can write a console getter function, for example test, and you use it on the template and you console log it. So you get to know how many times on component change detection has been executed. And this is another way, like using ng after view check event, you can put console log and see whether the change detection has been executed or not. So these are the way to measure the change detection. Now let's go back to the original way. We look at the default, right? Now we will look at what is on push strategy. We took the same example, okay? Network API call, task, and start event, which is this guy. Can anybody guess how many times the change detection will execute for on push strategy on this component? 1, 2, 3. Okay, why 1? 2, okay. Okay. So since the time is less, so I will say the 1 is correct answer. The reason is button click event, right? It is browser handle event. So the on push works a little bit different than the default. We will come what is the difference between these two, but over here it only execute one time. So we'll see first while running this code. So this is the simple application this I run, and you can see the code is on the right side same way. When component, this 3 tasks, I click on this guy, okay, and take a look at this count. This count is nothing but the count I somehow maintain on the component level. I click on start event. Oh, sorry, we should check on push. This is not on push code. When on push. On push. Yeah, that was the earlier one. Let's refresh. See what happened. It just executed incremented the count of the child component by 1 only, because what is that event is? Start event is a browser event, that's why it executed. So how it works? So to check that first, we will see how it works with on push. It's a bit tricky. So let's go over the points. Basically, it makes sure when browser trigger event happens, it runs change detection. Then if you do something with async pipe, it will also help to run the change detection on your component with on push. Of course, you can run manual change detection, right? You can include the change detector ref in the inject and run it, detect changes or mark for check. And the last one is input property change. This is very important. You know what this means, input property change? You can pass input properties or data to the component, right? So we have to make your component smart. So generally, on push strategy will be used in a case of you passing an input, and if the input change, your component should make a changes. So this one is the major one, and the other 3 were used for on push. So now we go back to the earlier example. Only this one was satisfied, right? The other 2 were not. So what we may do is we may apply one of these 3 things. The input property change may not be applicable, so I will do maybe manual CD run to check. Okay, so for example here, maybe I just do one here, maybe CD mark for check and see if it works or not. It should say now 3 after 2 seconds. Wait, oh, okay, wait, detect changes. Am I looking? No, I was changing the wrong code, so sorry. It should be when on push component, which is situated here, and I make a changes here. Now you supposed to see this one mark for change. I click here. After 2 seconds, it should increment it to 3. The same thing if I might do inside the network HTTP call, it will work. Okay. So to verify a theory, I know to verify a theory, what we can do is we can have another example which is bit different than the very simple one. Okay. So in this example, what we have a parent component. So this one is the parent component. You look at, there is two things in the ng-on in it. One is set interval, which execute each time on 2 seconds. Then there is one more interval which execute on 4 seconds each. And what happens is, if you look at the other side, the downstairs here, we pass the data of child data, and the other one is child 2 message into the child component. Their HTML is on that side. Okay. So what happens in this case? So basically what happens is I do have the mark for check there, so it will execute the change detection, but let's see the without that first. Wait a moment. So let's go to other route called as normal CD. Okay. I refresh the page first, and normal CD code is somewhere in the parent. Okay. So suppose, over here I just already executed, but let's see if I don't put it here and what happens. So each 2 seconds the value is changing, the child data 1 value and child 2 message, but the child component, those are basically getting those value are not reflected. How those are passed? You look at here. Is it visible at the back? No, then I can zoom in a bit. Yeah, correct, right? What is expectation? As soon as child 1 and child 2 message data updated, we are expecting it to reflected on child 1 component HTML, right, which is passed as a input over here, correct, which is not happening. And the reason is same what we have seen in the last example. So the way can be, you can use mark for check or maybe async pipe. This is not an API call, otherwise we could have used async pipe. So in this case, as soon as we do the change here, see on each 2 seconds in the child 1 component, the CD count, the change detection count increases, and the data value also reflect to mat.random, which is we already done here. Okay. So that was on push. So let's move on and see how it works technically. So let's revise, meaning the same thing over here. So let's take an example of click event happen on the child component. So this is the same hierarchy. Suppose somebody click on child 1 component or trigger a click event. What happens is it again intimates the main root component to trigger a change detection. And what happens is, since the property got, so example, our intervals were changing the properties, right? Those two property, a message and the data. So it reflect on the child 1 component. At the same time, it in this example, I just assume that the child 2 component may not be executed. So what could happen is, it may restrict the child 3 to execute in that manner. So basically over here, this example is saying like child 2 property did not updated, whatever we have been passing. So So that was one example, and one more is, wait a moment, okay. So one more is what happens in the other case, okay. So take an example of a grandchild. Suppose we do write a mark for check at the grandchild, which is very bottommost. So this scenario applies to a case where suppose we have a 100 level of component tree, and at the very bottom we trigger a change detection. For that we generally do mark for check. So what happened in that case? When you do mark for check, as soon as you do that, it started traversing back to the root of the component, and each time it goes back, if you look at the legends here, it says like it puts some flag on the component view level, okay. And as soon as it reaches to the top, it again traversing back to the top to the down. So what happens is, it say, okay, app component, okay, it was marked, so just check for a binding update, do it if it has. The child one binding may not be updated, so don't go for it, skip the check. Then same for child 2 component, there was a binding update, so it executed the change detection, same for grandchild, okay. And to support our theory, I was saying like async, one of those 4 options, I was saying async pipe may execute mark for check, right. So this is the proof of that. Like if you look at the async pipe code in the Angular example, it executes something called as mark for check on the change detector ref. So that is how it does, okay. So now coming back to few of the challenges that onPush may have. Each time when Zone.js let Angular know the change has been happened, the change detection always trigger from the top, okay. So currently we do all global change detection, and what happens is from top it travels to the bottom by checking for property change, and if it happens then it updates it basically triggers the change detection on that component level, okay. It works, but assume that your application has 1000 level of component tree, and doing that is super expensive operation, right. That may not be worth, okay. That was one problem. Also with current change detection, it is very hard to predict where exactly change happened, because Zone.js is taking care of those things like handle browser event and whatnot. If it is onPush, it is doing in different way. So it is very hard to predict the things. And also the third problem I already mentioned. So that's why Angular introduced something with Angular 17. There is something called as local change detection. This is also called as component level change detection. How this works? Basically, the way it works is using Signal, which is new API introduced recently, okay. And it basically helps to provide a fine-grained component change detection execution, control over the change detection execution, and you must have Signal used with onPush change detection strategy. Otherwise, you cannot utilize the local change detection thing, okay. So basically, how it works? Let's look at it. You remember these four things were applicable for onPush. Now, the local change detection say it will happen when Signal updates, and that Signal is used on template of the component, okay. That time the local change detection will trigger. We will take an example, we will not just see the theory. So let's take this example where we have a Signal component, and on ng-on init what we are doing, line number 11 to 18, basically we are maintaining some last value, and we just want to update the last value when it reaches to particular criteria, which is mod 3. I just took a simple example, don't want to overcomplicate things. And as soon as it happens, it updates the signal, otherwise it escapes from the condition. And this is interval, it keeps on happening, right? So as many time it goes over, it triggers a change detection, okay. So what happens in this case? Let's look at it. Is it visible? Okay. Let me zoom out a bit. Okay. So I need to uncomment some code. I will do that first. Over here, I just uncomment a code so that it matches with the slide and see what's happening right now. The top level, we have the component level count, the root component level count of change detection executed. It keeps on incrementing. Okay, there is child component and the other child component 1 and child component 2. They keeps on incrementing based on 2 or 4 seconds. Okay, so right now it is a bit confusing to check basically what's happening. So what I do is I go inside a child 1 and parent component, and I change the timer to maybe unreachable way, meaning it won't update any binding. So as soon as I do that, if you look at this child 1 data, it has been passed as a signal to the components, right? So see what happened. Let me refresh the page. Observe the counts. The child 2 is a parent component, right, to the grandchild component. In grandchild component, we have updated, one moment. Can I zoom out a little bit? Is it visible at the back? Okay, yeah. So see what happening in grandchild component, which is at over here. See what we did. We have the count at the grandchild and new signal value is updated. But you check, the parent of the child component is not triggering the change detection at all, right? And how that is happening. So this is the phenomenon, how it works. First we will see the diagram and then we come back to this to understand it better way, and so that we can relate it properly. So let's look at this. What happens in case of this specific case? In this case, what we did is we have a set interval at the grandchild component. Okay. So as soon as that happen, it basically generates something. So what it is it says it has to refresh a view. Okay, the red sign indicates a refresh a view. What it happens is, as soon as it travels back, since it was a local change detection according to those conditions, it marks the parent component not mark for check but skip for check. So which is, the other legend, and it keeps on doing that until it goes to the top. And now it started triggering the change detection from top to bottom. Okay, it execute here. Wait, did I? Oh, sorry. I'm so sorry. I think I have something wrong with the slide. But basically, what should have happened? It just triggered the change detection for grandchild and not everything else. I think I shuffled the slide maybe. But yeah, it just triggered a change detection for the grandchild, nobody else, which are red only. The yellow ones are skipped by the local change detection strategy. So now if you go back, I will refresh the application. Now you see who is the parent of this grandchild, child component 2, right? And at the top we have parent component. So you see the count is incrementing here, 12, but the parent counts are not reflecting. Okay. So that was a local change detection, which is basically signal update should happen and it should be on the template, and then the local change detection will be triggered. Let's talk about zoneless change detection, what exactly it is. Currently, Angular is relying on something called as Zone.js. So Angular is thinking of getting rid of that Zone.js so that the change detection will be controlled by the framework. For that, Angular has introduced something called as Scheduler API that internally help Angular to schedule a change detection and run it. You don't have to worry about it basically. It's just an extra information that I'm going to give. What will happen? One thing, it will help you to fine tune your change detection in a way. I will demonstrate that, and also it will help you to shave off 20 KB of Zone.js bundle. I think it is, to be exact, it is 22 KB. So you will get rid of that bundle size. So how to do that? No need to much worry about it. The way to do that is you remove the Zone.js library from AngularJS, and we write provide zone change detection, right? Instead of that, you will be using provide experimental zoneless change detection. Okay, this feature is not yet ready. This is in experimental mode. In V20, it may go into developer preview, but still you shouldn't be using on production until it goes to the proper state. So just I am letting you know, you may give a try of having this, but my one advice, if you are going zoneless, to get it used properly, I think you might have your all component migrated to on push first, so that you get a benefit of local change detection, and then also then you can easily go to the zoneless to get more benefit of the zoneless change detection as well. What are the key takeaways from the talk? We checked how the change detection works. Basically, it depends on Zone.js if it is default, and it triggers a change detection on those two criteria. For on push, basically it relies on 4 criteria, those I demonstrated. But with local change detection, it has an additional criteria, signal change, and it should exist, that signal should be displayed on the template. And the last one is zoneless change detection, where we will be removing Zone.js, and under the hood uses the signal API for doing that. And last thing, future signal component is one of the thing that is coming in. No commitment on that, but that may come, and that will improve the change detection of process a bit more. And yeah, I think that will be another topic. What could happen in that case? Just I will explain. Currently, what happens in the change detection whale, right? We click somewhere and it reflects on the UI based on 4 criteria. Probably in future, a change detection may work on signal, which signal have been changed, okay? And basically, which signal have been changed, meaning, a signal can be dependent using computed and effect. Yeah. So in that case, what would happen is, somehow in signal component, sorry, my time is up, so I will take 1 minute. Okay, so sorry. Yeah. So in signal component, what will happen is, they will completely somehow prepare a dependency graph of signal, and whichever signal impacted, based on the dependency graph, they somehow calculate which component to update, not to come from top and execute the change detection. So that could be the direction that Angular will go with future signal components. And I think, yeah, that's it, and thank you for listening. You can see the slide here by scanning the link. Sorry.